Alright, in this video we're going to look at a more concrete problem, maybe to get some of these concepts under our belt, and see how the integral is used in relation to velocity. So what I have here is a velocity graph. Okay, I'm going to put t here, and the units here are hours. And my velocity is in, according to this, miles per hour. Okay, and this is my actual graph. So this says, suppose a car travels along a straight road according to the velocity function, v of t is equal to t squared minus 4 on the time interval 0 to 5. V is measured in miles per hour, t is measured in hours. Sketch the velocity of the function over the interval. Well, that's what I've already done for you. During what times is the car traveling in the negative direction? Let's review that. That's a concept from differential calculus, not integral calculus, but we should review it anyway. So negative direction. Well, you're traveling in the negative direction whenever your velocity is negative. Okay, so this happens when your velocity, well, I'll write it in words, when your velocity is negative. And so if you look at your velocity graph, that is happening on the time interval 0 to 2. Okay, so in our case, that would be in the time interval 0 to 2. Okay, so that was the negative direction. How about the positive direction? Well, that's when your velocity is positive. And we can see from our graph up here that that is happening on the interval 2 to 5. At what time does a car change directions? Well, a car changes directions when its velocity is 0 and it changes sign. Okay, either from positive to negative or negative to positive. We can tell from our graph that at time 2 is when our car stops and then changes from going in the negative direction to the positive direction. Okay, now we've got some questions involving the integral. We have to evaluate these integrals, and then we want to interpret what each of them mean. And obviously we're going to include units. And so then we'll return to that last question about suppose the car starts at 4 miles away from checkpoint. So we can do this by hand using the fundamental theorem. If you see my velocity function, it's t squared minus 4. We're going to be a little lazy because the point of this is not so much to assess your fundamental theorem skills, but really just to interpret things. So I'm going to use a calculator to do this. So we're going to evaluate all these using a calculator. And so I'm going to split screen here. I'm going to use a calculator. All right, and so I'm going to integrate my velocity with those varying limits of integration. So I'm going to hit math. I'm going to go to fnint. Okay, I'm integrating. My first one's from 0 to 2. And my function, of course, is x squared, or I'm going to use x squared minus 4. Press enter, I get negative, that's negative 5 1/3. So let's write that. Let's use some other colors over here. Okay, that's negative 5 1/3. Now you should recognize that expression as a change in position. And so that would be negative 5 1/3 miles. Let's do the next one, 2 to 5. So I'm going to use my calculator in a clever way. I'm going to do that to copy, and then I'm going to go just change the limits of integration to be from 2 to 5. $27. Okay, that would also be a change in position from 2 to 5 hours. 0 to 5 we can do. So again, let's copy this. (21 2/3). Okay, and at this point I don't think I need the calculator anymore, because if you look at the next expression, it involves two of the things we already know. So I'm going to get out of here. Okay, and so what I should point out is these are all giving you change in position. Those are changes in position. The first one is a change in position from 0 to 2 hours. The second one is 2 to 5 hours. And the third one is the entire time interval, 0 to 5 hours. So the first one, giving a negative, it means that you're 5 1/3 miles in the negative direction from where you started at time 0. The second one means you're 27 miles in the positive direction away from where you were at time 2. And so at time 5, you're 27 miles away from where you are at time 2. And then, of course, the third one is that you are 21 2/3 miles away from where you are in the positive direction at time 0. So we'll be clever about this next expression. This integral is from 2 to 0. Notice by properties of integrals, that's just going to be the opposite of what we got over here. So I'm just going to say this evaluates to 5 1/3. Okay, just switching the limits of integration. And then the integral from 2 to 5, I think we already have, which is 27. So if you add those up, you get 32 1/3 miles. Now that is your total distance traveled. Now the reason I know that's my total distance traveled, so that's your total distance traveled. From time 0. And the reason I know that is because, well, first of all, I could always express total distance as in one integral using absolute values, right? So this is going to be equivalent to the integral from 0 to 5 of the absolute value of my velocity function. But the thing to notice is that our velocity changes from negative to positive. So when you collect area, as we did in this integral here, if you collect area, you're going to get some negative area, right? You're going to get this negative area, and then you're going to go get some positive area. Just get it better. Sure, this is fine. Right, then you're going to get some positive area. We want to count it all as positive. So you can either take the absolute value, of your velocity function, which would have the effect of, right, moving this bottom curve up and counting it as positive, but by negating the area from the integral from 0 to 2, you have an effect to do the same thing. All right, one last question here we'll answer. It says, where is the car in relation to checkpoint at t = 5 if we know that the car starts 4 miles away from checkpoint on the positive side initially? And this is where we're going to use our scaffold here. So position, okay, your position at any time is your position where is your starting position plus how you changed. Okay, so your position at time 5 is what they're asking. Your position at time 5 is where you were at time. So it says, suppose the car started 4 miles away. That's at time 0. This situation starts at time 0. So it's where you were at time 0 plus how you changed on the time interval 0 to 5. Now they told us that this is for the integral from 0 to 5. I believe we accumulated. It's up here. It's that in green, 21 2/3. So where I am, 21 and 2/3, where I am at time 4, or time 5, is where I was at time 0, plus how I changed on the time interval 0 to 5. So or the car rather, is at position 25 and 2/3, okay, which is obviously the positive direction since it's positive. I don't really need to say in the positive direction since the value is positive, but we should interpret it, right? It's 25 and 2/3. It's at the 25 and 2/3 miles in the positive direction. All right, so that was just an example of applying some of these concepts to a particular problem involving velocity and the definite integral.